So let's talk about area, volume, and surface area. Okay. So I'm going to start off by giving you a handful of formulas for area. But first, what is area?
It's the inner part of the hole.
Yeah, it's the inside part of the shape. So for example, if I were to give you a rectangle, let's say, a rectangle, the area of the rectangle would be how much stuff is in here. Okay? We have a formula to find the area of a rectangle. The area of a rectangle is the length of the shape multiplied by the width of the shape. You will frequently see this written as L multiplied by W. Length times width. Okay? All right. Shape number 2, the square. The noblest of the quadrilaterals, the square. The area of a square could also be length times width. A square has a length and a width, and if you multiplied them, you would get the area of the square. But one of the advantages of a square is that the length and width, the two sides, are the same. So the square is the side multiplied by the side. You will see this written as S squared. I suppose I should make this whole thing complete here and actually label. Let's go back up here and label these so there's no confusion. Like, square side. So area of a square is S times S, S to the second power. What's another way I could say S to the second power?
Square.
Hey! Are you telling me the area of a square is the side squared? Well, that's an incredible coincidence. It's the area of a square and the name of it is squared. That's nuts. I can't believe what a coincidence that is. It's not a coincidence. That's the reason something raised to the second power is called squared. It's the area of a square. Is your mind blown? Nope, just me? Okay, fair enough. Moving on. Let's do a little trickier one. This shape is called a triangle. It's called a triangle because it has three angles. Triangle. Triangle. Now, when we do a triangle, we need a really important measurement. This line going straight down the middle. This is the height of the triangle. We need to know the height of the triangle. And we also need to know how long this bottom side is. We call that the base. And the reason we need to know those two sides, the height and the base of the triangle, is because the formula for the area of a triangle is half the base times the height. Or 1/2 b. Half the base times the height. That's because a triangle is half of a rectangle. So you're really finding the area of a rectangle and cutting it in half. Okay? This shape is called a parallelogram. Really not very good at naming things in math, so we took the shape that has a bunch of parallel sides and called it a parallelogram. Much like the triangle, we need to know the height of the parallelogram. And we also need to know the base. Height and base. Area of a parallelogram is much simpler than the area of a triangle. It's just base times height. Or you could say A equals B times H. Don't get mixed up with a parallelogram. The height of a parallelogram is not the length of the side, because the sides are generally at an angle like this. The height is literally how tall is the shape, which is often smaller than the length of the side. Okay, and the final shape also has the weirdest formula. This is called a trapezoid. We need to know the height of that one as well. A trapezoid, though, we also need to know the base of the trapezoid, and because the bases are different, we call this base 1, or the top base, and we call this base 2, or the bottom base. We call it one base and other base, whatever you want to call it. The area of a trapezoid is a weird formula. It's 1/2 base 1 plus base 2 times the height. That is a goofy formula. A lot of times you will see the two bases separated by one being lowercase and one being uppercase. So sometimes you'll see it written like that, which is fine. So you can see a lot of similarities between these formulas. Most of them involve base and height. Even if we don't always call them base and height. Sometimes they're called length and width, sometimes it's called the side, but basically it's base times height. And the ones with some weirdness in them are the triangle. It's half the base times height, because the triangle is half of a rectangle. And the one that's super weird is the formula for the area of a trapezoid. And the reason that one's weird is because the top and bottom of a trapezoid are different lengths. So we gotta take that into account when we do the formula. Okay? So let's try some of these. Let's try a triangle. I'm going to tell you the height of this triangle is 6, and the base of this triangle is 13. All right, what do we do? Well, if you go back to our formula for triangle, area of a triangle, the area of a triangle is 1/2 times the base times the height. Okay? So my area is going to be 1/2 times, what's the base? 13 times the height, 6. So half of 13 times 6. So a little multiplication trick here. If I do half of 13, 1/2 times 13, I'm going to get a decimal, which I don't love the idea of dealing with a decimal if I can avoid it. But with multiplication, the order in which you do it doesn't matter. So I can do 1/2 multiplied by 6 first. What's half of 6? 3 times 13. And 3 times 13 is much nicer than doing half of 13 times 6. And the area there of that particular shape is 39. That doesn't seem bad at all. In multiplication, the order doesn't matter. Okay, let's try another one. Let's do everybody's favorite shape with an excessive number of L's in the name, the parallelogram. We need the same measurements for a parallelogram that we needed for a triangle. And just because I'm trying to ruin everybody's life, let's go ahead and do some decimals here. We're going to make this an obscenely large parallelogram. 2.5 kilometers tall, almost 6 kilometers wide. This is a monstrous parallelogram. It's the only kind of parallelograms we tolerate in Texas, the big ones. So the formula for area of parallelogram, let's go back to it. It's just base times height. It's literally just multiplication. So the area here is the base, which is 5.9, times the height, which is 2.5. Okay, so we need to go ahead and multiply this out. Okay, so we'll very quickly multiply this out. Make sure you check me. I'm not so good with the arithmetic. Don't let me get away with anything. I got 14.75. If you've got a calculator, you are welcome to check me. If I'm wrong, just keep it to yourself. And if I'm right, you should all shout, Taylor's the best. No? Don't want to do either one of those. Okay, that's fair. That's fair. Let's do one more. Let's do one that's not in our list of formulas. Do everybody's favorite shape, the robot boot. Who don't like the robot boot? Why? Is that what you just asked? Why? That's a good question. Why is a good question. My God, why have you forsaken me? That's a good question. All right. So there are a couple of problems with this shape. The most pressing concern for me is that we don't know all the sides. I think we could probably figure the missing sides out. Once we find the missing sides, though, we're going to have a new pressing concern, which is that I don't know what formula to use for robot boot. I don't remember that being in our list of formulas. But let's one thing at a time. One thing at a time. Let's see if we can figure out the missing side. So here's one of the missing sides right there. How big's that one? That's 3. The whole thing's 8. This is 5, so this would have to be 3. Good. And then we need this piece right here. That's going to be 8. Whole bottom side's 12, which means the whole top side should be 12. This is 4, leaving 8 over here. Cool, so if I wanted to know the perimeter, I'd be all set. I don't know what to do here because this is not a shape that I'm familiar with.
You have to break it down.
I could break it down. How do you suggest I do that?
Like draw imaginary line with the small box, which is like to get the area.
Like from here to here?
Yeah.
Okay, so the suggestion was let's separate this into 2 pieces. What advantage do I gain by separating that into 2 pieces? Yeah, now I got 2 rectangles. I got tiny rectangle and I got big rectangle, and I know formulas for rectangles. Okay, I'm in business. I like this idea. So let's start with the tiny rectangle. That's going to be 12 because the height we calculated was 3. and the width is 4. So the area of tiny rectangle is 3 multiplied by 4, which is going to be 12 feet. Outstanding. Okay, now I got to do the area of big rectangle.
Which would be
12
5.
multiplied by 5. That's the area of the big rectangle. 12 multiplied by 5, which is 60 feet. Okay, so I got the area of the little one. I got the area of the big one. Now what? I put them together. The area of the whole shape, 12 feet plus 60 feet for a grand total of 72 feet. Outstanding. Good job. Oh, that is such a good idea. So what she said was, the way she solved it was, she figured out the area of the entire theoretical shape, meaning she pretended like it was one giant rectangle with a height of 8 and a width of 12. 8 multiplied by 12 is 96. So the area, if this was a rectangle, would be 96. It's not a rectangle because we're missing this red chunk right here. But we know the area of the red chunk because this is 3 and this is 8. So 3 times 8 is 24. So you take the area of the whole thing, which is 96, and subtract the little rectangle, which is 24. So the area could also be 96 minus 24, which is 72. Very creative way to get that answer. Very well done. I can tell just by the quality of that exceptional math answer that you must have a math teacher that is really, really good looking. I can tell. People with ugly math teachers can't get that answer. That's just a fact. All right. Well, we've done a whole lot of these polygon shapes. There is one shape that we haven't really talked about yet. Ah, the good old circle. Revolutionizing the auto industry. Good job, circle. So, when we talked about circumference, when we were discussing perimeter, there were two different formulas you could use for circumference. There's only one formula you need to know for area of a circle. Just like that circumference formula, we do need to know one of the pieces of the circle. Specifically, we need to know the radius. And once you know the radius, we can do the area formula, which is pi multiplied by the radius squared. Say that again?
So where do you get radius squared from?
Well, you'll be given either the radius or the diameter, and then you just use that.
So your radius squared is just like half a diameter, because you're times radius twice.
Right, that's exactly right. So if I just gave you the radius, well, let's just do one. There's a perfectly circular shape right there. Nailed it. Let's say the radius was 3 feet, like that. I would just do pi multiplied by the radius squared. The radius is 3, so 3 squared. If I wanted the exact unrounded answer, 3 squared is 9 times pi, and I would just stop right there if I wanted the exact answer. That is the unrounded answer. I know it looks weird to have a symbol in your answer, but it's cool. We'll allow it. However, if I wanted to estimate the answer, like an actual number, I could multiply the 9 times 3.14. Remember, 3.14 is not pi, but it's a pretty decent estimate. So let's do 3.14 times 9. got a calculator, definitely check me. I mess up all the time. 28.26. That is not an exact answer. That is an approximate answer. The reason it's not an exact answer is because pi is not really 3.14. I was estimating. It is. Radius is half the diameter. In both cases, I need to put my unit here. Feet.
So if we had the diameter, could we just do the diameter times pi?
No, that was a really good question. He said, if you had the diameter, would it just be the diameter times pi? And the answer is no, because a number squared is not the same thing as 2 times a number. So let's say I give you the diameter, and I say it's 10 feet. My formula I use is still going to be pi r squared. The only difference is I wasn't just given r this time. I was given the diameter. Let's put the center in there so we know it's really the diameter. I wasn't given r. I was given d. So what is the radius in this problem? 5. So it would be pi times 5 squared. So the exact answer would be 25 pi. If I just took this and multiplied by pi, I would get 10 pi for the answer instead of 25. So squaring is not the same thing as doubling. Okay, feeling all right about area? Okay, so let's move on from area into volume. What's volume? Other than how loud something is, what is volume? So you said liquid. It doesn't have to be liquid. How much something can hold. That's volume. How much stuff it can hold. Doesn't have to be liquid. Could just be air. How much air can something hold? So, no mocking my drawing skills here. I'm going to draw some 3D objects for you. Flattery will get you everywhere. Okay. So this shape, do you know what it's called?
Rectangular prism.
Oh, it is called a rectangular prism. My gosh, your math teacher is handsome. This is called a rectangular prism. So good. Who taught you that word?
Mr. Taylor.
I don't think I did teach you that word.
No.
I'm impressed you know it, though. That's a rectangular prism. Any idea how to find the volume of a rectangular prism?
Length times width times height.
It is length times width times height. So it's similar to area. We're going to start off with length times width, which is the base of this shape. Right? Length times width is the base of this rectangular prism, which is a rectangle. So we're starting off like it's a rectangle. The only difference is we can imagine this is a whole bunch of rectangles stacked on top of each other 2 inches high. So we take the area of that rectangle and multiply by our stack of rectangles. That helps you think about it. So we're still just multiplying. That seems pretty easy.
Changed this in all the years. Right?
Say that again?
I go to Home Depot a lot. It seems to me they're trying to do something different in this formula.
People at Home Depot are doing something different from this formula?
Yeah.
Well, I think that means you need to start shopping at Lowe's. People at Home Depot probably can't be trusted. They must have had an ugly math teacher. So all we're doing is replacing length, width, and height with these numbers. Length was 6. Width was 8. And the height was 2. I said this a little while ago, but it bears repeating. In multiplication, the order that you multiply in does not matter. It doesn't matter what order you multiply in. So I can do 6 times 8 and then times 2, or I can do 6 times 2 and then times 8. It's kind of whatever you think's easiest. I think multiplying by 2 on the end actually is the easiest thing to do. 6 times 8 is 48. I think doubling a number is pretty easy. 48 times 2 is 96, so 96 inches. How do you feel about 96 inches?
Feels about right.
Yeah? How do you feel about inches? Is inches the right unit?
Are you trying to convert it to feet? or-
It's cubic inches. Why is it cubic inches?
Oh, because of the
Volume is measured in cubic units. You know what that means? Means we forgot something on our area answers. Because if I go back and look at the area answers on the parallelogram, we just put kilometers. That wasn't really kilometers, was it? It should be square kilometers. That wasn't really 72 feet. It was 72 square feet. Our circle wasn't 9 pi feet. It was 9 pi square feet, or 28.26 square feet. Make sure you get the units right. Next time you go to Home Depot, when you ask for a supply, you typically measure in square feet. Like if you're going to go ask for some tiles for your floor, the question they're going to ask you is how many square feet do you need to cover? And that's why. Okay. All right, now you really can't make fun of this. I'm going to need all your positivity right now.
Sphere.
How do you even draw a sphere here? I feel like I should shade it somehow.
You gotta do 2 of those little lines in the middle.
2 lines.
It
Huh?
lines out.
Can I draw it for you?
Yeah, here, draw them.
You gotta push that like this. Something like
okay,
that.
Okay, I like that.
You
Oh,
feel
okay,
me?
that's pretty good. That looks like a sphere, right? Yeah, okay, excellent. Now, a sphere is a 3-dimensional circle in the same way that a rectangular prism was a 3-dimensional rectangle. So, just like a regular circle, we need the radius of this sphere. This is like the center of a basketball coming out, except I don't actually know the radius of a basketball. What seems reasonable? Like 6 inches? 8 inches? Really? You think a basketball is 16 inches in diameter? That seems big.
16, 18.
Really?
Yeah.
That seems big. I guess there's only one way to find out. We're going to have to sacrifice a basketball and measure it.
Oh my.
Okay, the formula for sphere is weird. For the volume of a sphere. Okay? It's still got pi r, just like a circle does, but with some more weirdness added in. It's 4/3 times pi times the radius cubed. Sweet mamba jahamba. That is a big boy formula right there. Now, the bad news about the sphere formula is that it looks like this. But the good news about the sphere formula is that it's got a good personality and it's beautiful on the inside, because you may notice that the only thing I need for the volume of a sphere is the radius. I don't got to plug in a bunch of numbers. If I know the radius, I'm done. And hey, look, I know the radius. It's 6 inches. So all I got to do here is take this volume formula and do 4/3 pi times the radius cubed, so 6 cubed. Whew, lordy. All right, well, we've done worse things than this. I can't think of any off the top of my head, but I'm sure they must exist. So the first thing we got to do is figure out what 6 cubed is. That's 6 times 6 times 6. Now I know what 6 times 6 is. It's 36. So I got to do 36 times 6 to get 6 cubed. So 216 is 6 cubed. All right. So 4/3 times pi times 216. Okay, so the next thing I got to do is 4/3 times 216. All right. Well, let's come do that over here. 4/3 times 216. Now, when you're multiplying a fraction by a whole number, it's not as difficult as you may think. You just turn that whole number into a fraction by putting it over 1, and you just multiply straight across. So I'll go ahead and do the hard part for you. 3 times 1 is 3. Anybody have the top part? Seems like it's going to be about 864. What do you think? All right, 864 sounds good to me. Calculator recommended. I feel like 864 divided by 3 is probably going to work out for me. I feel like 864 can be divided by 3, and here's why I think that. Here's a little trick for you if you want to tell if something can be divided by 3. If you can add up the digits of the number, and that sum is divisible by 3, then the whole number is divisible by 3. This is what I mean. 8 plus 6 is 14. 14 plus 4 is 18. So the sum of the 3 digits up here is 18. 18 can be divided by 3. That means 864 can also be divided by 3. It is going to be 2 something. 288. Good. So 4/3 times 216 is 288. Back to my problem then. The exact answer is 288 pi inches.
You got the 3.
I did forget. Inches cubed. Good job. That is the exact answer. If I wanted the approximate answer, I would take 288 and multiply by 3.14. And there's probably no reason for me to do that. Everybody could do that in their heads, right? Yeah, so we probably don't need to go over that. I feel like you nailed it. We'll never know. We'll never know what 288. I mean, it's impossible. Who could possibly figure that out? I think I'm gonna stick with the exact answer. Okay, here's a new shape. We're going to do a cone next, but I got to tell you, I'm really putting it off because I don't know how I'm going to draw a cone. That's going to be tricky. Man, I should have paid attention when Draw Squad was on in art class. Should have paid attention. So we're going to give the radius of this cylinder. Oh, sorry, I guess I should name this. This is called a cylinder. Oh, I might have just spelled that wrong. Does cylinder have 1 L or 2? 1 L? Oh, definitely spelled it wrong then. Cylinder. Okay. For a cylinder, you need to know the radius of the top, and you also need to know the height. If you had to guess, what would you say the area is for a cylinder? You actually know enough information here to do this, because if you go back to our rectangular prism, The bottom was a rectangle, so we found the area of the rectangle and multiplied by the height. If you look at our rectangular, or if you look at our cylinder here, what shape is the bottom of that? A circle. So we can find the area of the circle and multiply by the height. Okay, so refresh my memory then. What is the formula for the area of a circle?
Or half, or was it?
You had it right. Pi r squared. So that's the area of the circle on top, and then I'm going to multiply that by the height of the shape. And now it's just a matter of plugging in the numbers. So pi times the radius squared times the height. I've said several times to you that with multiplication, you can do it in any order you like. This is not all multiplication, though. It has an exponent. You have to do exponents before you do multiplication. So saith my dear Aunt Sally. So I got to do the 3.5 squared first. $12.25? Great. You are required by the laws of Aunt Sally to do exponents before you do multiplication. Now, once the exponents are done, order doesn't matter, although there's really only one thing left to do, and that's the 12.25 times 6. I'm definitely going to multiply by pi last so that I will have access to the exact answer. So I'm going to do 12.25 multiplied by 6. So 73.5, somebody check me please. Yep, okay. So 73.5 pi is the exact answer. And if you really had a wild hair and you wanted the approximate answer, what would we do? I would take 73.5 and I would multiply by 3.14, or multiply by 22 sevenths. 22 sevenths is an acceptable way to get that. All right, here's the last shape that we're going to talk about with volume, and that is the cylinder. Y'all pray for me. Here's my idea for a cylinder. I'm just going to go, yeah, I'm just going to round it, and then I'm going to do,
Not bad.
that seems all right, yeah? Oh, thank you, thank you. I know, I was touch and go there for a second. So, a cylinder, I need the height. Let's call that 14 centimeters. Oh, wait, hold on. We forgot the unit on this problem. 73.5 pi what? Cubic inches, yeah. Well, better not forget. There we go. Okay, good. All right, I feel better now. So 14 centimeters. I also need the radius of the base because that's a circle. That's going to be 3 centimeters. All right. The formula for this shape right here, do you know what this shape is called? It's called a cone. The formula for this one's weird. I don't know. Whoever came up with this formula is a genius. Was a genius. I feel like they're probably not with us anymore. Rest in peace, cone guy.
I believe the reason why it's third is because it's kind of like a triangle, right?
I think that's a reasonable assumption. It's
1/3 of the.
It's 1/3 of a cone because a cone was pi r squared h. I mean, not 1/3 of a cylinder. A cylinder was pi r squared h, so a cone would be 1/3 of a cylinder. That seems reasonable, I guess. Anyway, this is not quite as nice as some of our previous formulas because you do have to put two things in there, the radius and the height, and then you also have to square the radius, and then it's got a 1/3 in there, and then it has a pi. So it's pretty gross, but we can handle it. So volume equals 1/3 pi times the radius, which was 3, squared, times the height, which was 14. Okay, 3 squared is not bad. 3 squared is 9. I have to do the squared first. Okay, now everything that's left is multiplication, and remember in multiplication the order doesn't matter. I can multiply these in any order. So while your temptation might be to do 9 times 14, there is an easier thing to do first. Do you see it? 1/3 times 9. What's 1/3 times 9? 3. 1/3 of 9 is 3. So 3 times pi times 14. And 3 times 14 isn't bad at all. The secret to life, life, the universe, and everything. 42 what?
42.
42 pi
Oh, three.
cubic centimeters. That is the exact answer.